Yeah, let's do it. It's just sitting there starting.
Okay. So I'm not seeing any glitches so far. It seems to have gone really smoothly, but maybe you see some in the background, but seems to have been pretty impressive.
Yeah, I don't know if we're live yet. It just says starting.
So we can't hear anyone, can we? So we've got no idea. So, yes.
No. Oh, no, we're live. Okay.
We are. Okay.
Hi, and welcome to Commsverse. This session is Simplifying the Public Cloud Maze, Designing Considerations for Microsoft Teams Voice. It's presented today by John Stewart-Murray from AudioCodes. Over to you, John.
Thanks, Randy. Thank you. So good afternoon, everyone. Yeah, so the topic today really is about how to deploy SBCs into the public cloud, really. We do an awful lot of those at AudioCodes. I'll introduce myself and AudioCodes in a second, but we do an awful lot of SBCs in public clouds, and we've learned over a few years there's a lot of design considerations you need to look at. So I've sort of tried to consolidate those down into some useful lessons, essentially. But just to introduce myself briefly, I'm John Stewart-Murray. I'm an AudioCodes pre-sales consultant, so my job really is to help our customers with any technical questions, queries they may have about how to use AudioCodes products, essentially. And AudioCodes, you probably, or you may well know, is a kind of global telephony equipment manufacturer, and I'll introduce AudioCodes in a few seconds. So yeah, here's the agenda: a quick intro to AudioCodes, and then look at SBCs in the cloud, so different kinds of cloud, public and private cloud. And then how we run high availability, because that changes the cost model significantly if you need to have run HA in the cloud. So look at what that means. And then really the key question about the cloud is how much does it cost? The cloud is great. CapEx solutions are painful at times. So OpEx is the way to go nowadays, but deploying stuff on a monthly cost can be significantly more expensive than a CapEx at times. And people often forget about bandwidth. Bandwidth can sneak up on you. It can be really expensive. So we'll look at how we can mitigate that and just how much you might expect to spend on bandwidth in the cloud. And that's it, really. We'll drop into a Q&A after that. It's going to be a reasonably short presentation, like I said, probably only about 20 minutes or so before we get to the Q&A. But if you've got any questions, please fire them into the Q&A and then we'll deal with them at the end of the presentation. Okay, so a quick overview of AudioCodes. We've been around for 25, 26 years now. We're actually almost 800 employees worldwide now, so we're quite a big company for this kind of space. We're no Cisco, but we've got a lot of employees, a lot of developers worldwide. We've got a very strong focus on Microsoft solutions. Probably 50% of our revenues are attached to Microsoft solutions in one way or another. But we also work with people like Broadest, Genesis, and all the other big kind of solution providers out there in the UC space and the telecom space. Our go-to-market is always through systems integrators and service partners. So we don't sell directly to end customers. We're very sort of proud of our channel, and we support it as much as we can with education sessions and a kind of pre-sales support and post-sales support as well. So yeah, if you're interested in becoming a partner of ours, please ping us. We like to think of ourselves really as a trusted advisor for telecoms. We've been in the business for a long time. We know how to make telephony work, really. We know it's not everyone's kind of meat and drink, so we do it on a daily basis. So if you've got questions, then come and see us. Okay, so a very brief look at our product portfolio. Let me just get a pointer up. Oops, wrong one, sorry. Let me just get a pointer up. I can. So we've got a wide range of products. So down this end here, we have our kind of gateways and SBCs that people know us for, really. These are a range of hardware and software SBCs, and then down the bottom we have our small ATAs that we can connect analog devices, telephones to. In fact, we even have a very big ATA, in fact, down here. So these are the SBCs and gateways, which are the kind of meat and drink of our business. But we have lots of other stuff as well. So we make a very wide range of both SIP and UC phones. So we support standard SIP like Broadest and Genesis, and also Skype for Business and Teams as well. So we have native Teams phones down this end that can connect directly into Teams. And also more and more importantly in AudioCodes now is the meeting room solutions. So we make audio conferencing solutions from a collaboration with Dolby, and we also now are just about to produce a collab bar. So that's a little bar that sits on top of your TV and turns it into a kind of smart video conferencing TV, which hooks into Teams. So that's coming out very soon. Then at the sort of top of the stack, we've got a wide range of software and other applications, which are used to kind of manage the SBCs and gateways, like our OVOC platform, but also manage users as well, like the UMP, which helps you migrate and move users, to and from Teams. And also, finally, we have things like our call recording solution, SmartTap, which offers both peer-to-peer and peer-to-PSTN calling in Skype for Business and now in Teams as well, just being released. So that's really AudioCodes in a nutshell. Let's have a very quick look at Teams direct routing, just so we kind of positioned and know what we're talking about. So direct routing has got really two different deployment methods. What we call direct routing enterprise is where you have an SBC here, which is connected up to Teams and then connected to a SIP trunk down to the PSTN. So if someone wants to make a phone call from Teams, the call flows through the SBC and out to the SIP trunk and off to the outside world, and vice versa, calls come in through the SBC and into Teams, and it'll ring someone's Teams client. So in this case, the SBC or the gateway is dedicated entirely for the use of one company. But what we've seen more and more with Teams, because Teams was designed much more clearly around a hosted multi-tenant platform, is that many of our partners are actually deploying kind of larger SBCs in a cloud somewhere, and they're using this, they're dividing this SBC up kind of logically into a multi-tenant function. So for example, this is a specific customer down here, and this is a different company down here altogether, and this is another company down here, and they're all sharing the resources of this single multi-tenant SBC and connecting to Teams and to a SIP trunk down here. And this gives you the possibilities of great economies of scale. And also you can do things like cookie cutter deployment. So if you're selling Teams direct routing solutions to small companies, you can very easily automate the SBC to roll out these solutions really quickly at a very cost efficient manner. So that's the kind of the scenario that we're looking at basically. So if we look at the kind of SBCs and how we can deploy them, AudioCodes have got lots of different SBCs, and basically they're kind of little to large. So we have smaller SBCs than these. This is the kind of mid-range start, 600 sessions here, up to 5,000 sessions, 30,000 sessions, 70,000 sessions, and higher. We now support nearly 85,000 sessions on this SBC, and that's a huge capacity of sessions. And we'll look at what that means in terms of users in a minute. But 85,000 sessions in any world is an awful lot of users. You could run kind of half of London off that basically. But what's big now really is software SBCs, and you can see that we do have quite high capacity in our software SBCs. Still, we can still run pretty, 50,000 sessions here, 25,000, 24,000 sessions here. But the one thing that's important to note is that all of our gateways and SBCs have got the same firmware, protocol stacks and support tools, etc. So as you go from little to large, from hardware to software, nothing changes. It's all the same interface. So it means that your understanding of how to deploy these things is exactly the same, and you can support them just as easily. So if we look at the SBCs we tend to use for direct routing, as I said, it's really a question of kind of little to large. You start out with the M800, as we call it, the Mediant 800, and you just kind of go up in size right up to the big Mediant 9000. So we have big sort of tier one service providers using this to provide kind of direct routing services to many thousands of people. But as I mentioned before, what's more and more important nowadays is software SBCs. They're really kind of filling the gap here and allowing people to roll out many more complementary solutions for Teams at a much more cost-effective model. So you don't have to pay us kind of £500,000 to buy a really big SBC up front. You can pay a kind of like a monthly fee at a much lower cost to help you build out a solution. And as your revenues increase, then you can pay us more, and it's a kind of partnership essentially, rather than a kind of customer manufacturer relationship. So it gives us the opportunity to have many more different models of delivering solutions. Now, with software SBCs, we support different numbers of sessions on different platforms. So if you look at this pop-up here, you can see that on Hyper-V, for example, we support 900 sessions. In Azure at the moment, it's quite low. It's 600 sessions. This is the number of sessions per hypervisor, per virtual machine. So Azure currently is actually quite low. It's about 600 sessions. This is going to increase end of Q2, which is pretty, well now, in fact, it's come, hasn't it? It's going to increase early Q3. In fact, it'll be about 2,000 plus sessions. But you can see in Amazon EC2 we can do 3,200 sessions, so that's a bit higher. And then in the private clouds it goes up and up and up to 24,000 sessions plus. So there's a significant variance in the number of sessions we support, depending on the hypervisor that we're running on, and that really does affect the cost model as we look at it later on. But we've talked an awful lot about sessions now, and obviously what really matters really is users effectively, because when you're selling a solution to a customer, it's obviously they're based on users. If they've got 500 users, they need a certain number of sessions. So it's a very good question, is how many sessions do I actually need on an SBC to support these number of users? Now, traditionally, sort of 20 years ago, when you had a PBX, you'd normally allocate roughly 10 users per telephony channel. So that what we call a 10-to-1 ratio. So if you had 100 users on a PBX, you'd normally need about 10 channels. So, kind of half of an E1 or something like that. Contact centers are usually around 1-to-1, of course, because people in a contact center are on the phone all day. So everyone needs one telephony channel basically most of the time. So 10-to-1 is the old days, as it used to be. And what we saw as Skype for Business came in sort of 5, 6, 7 years ago, we started to see a change because Skype enabled federation. So different organizations could talk to each other using voice over IP effectively, just as you can with Skype and Skype consumer as well. So it means that, if I was ringing up a customer and the customer had Skype, then we would be talking on Skype. The phone call wouldn't go over an SBC. And that obviously had an impact across the whole business. And what we started to see was the typical concurrency ratio that people needed for a solution of an SBC started to go down. So typically we were now seeing something like 25-to-1 as a typical kind of contention ratio that you'd need. So 25 users for each session. So that means you need less and less telephony, for each sort of deployment. So now if you're deploying to a solution with 500 customers, you might need 20 sessions. Okay, so it's going down significantly. It's falling away as we stop using the PSTN more and more, essentially. And Teams, we found, has accelerated that trend because Teams has kind of federation built in effectively. You don't have to choose to federate, it's just there. And hosted SBCs are very popular. We're seeing more and more Teams direct routing solutions out there, which means more and more people are talking to each other. So for example, this conversation we're having now, this is all based on Teams. It's not going anywhere near an SBC. So there's 50 of us on this call at the moment, or maybe more, and we're all just talking via voice over IP, no SBCs involved. And that trend is going across the whole industry. So what we're seeing now across quite a wide sample range, because we've got lots of customers, with lots of SBCs, with many thousands of sessions deploying direct routing. We're seeing ratios of kind of typically 50-to-1, and in some cases it's going up to 100-to-1 up there, which is a tiny number of sessions. So if you've got 1,000 people in an organization, you just need 10 sessions. That's a very small number of telephony calls every day. But what's really important is that even though the number of calls are going down, is that everyone still needs the ability to make a phone call. You can't predict who's going to make a phone call. You can't go through a company and say, do you need to make phone calls? Do you need to make phone calls? You've just got to assume that pretty much everyone's going to make phone calls at some point and obviously control it in a way, but you can't take away that functionality. So it means you still need the sessions there, but you don't need to necessarily have as many sessions as you might have needed in the past. So just remember that contention ratio as it goes down and down and down. So that's kind of the number of sessions. So how does that kind of map into kind of virtual machines that you might put in the cloud? So we support many different types of public cloud. We can run in Azure, in AWS, in Google Cloud Platform. We can also run in the sort of hybrid or the private clouds. So things like KVM, OpenStack, VMware, ESXi, etc., and lots of other ones as well. We can run in all these different public and private clouds, and obviously we use, as I mentioned before, different VM sizes to support different capacities. So as I wanted to talk more about kind of Azure now, I'm going to focus in on Azure and then maybe sort of compare that with AWS. We'll leave the kind of private cloud behind now for a bit and just talk about the public cloud instances. So if you look at the virtual machines we need to support different session counts in Azure, you can see these are the different machine types in Azure. So if you're not familiar with Azure, you probably don't recognize these, but these are the typical kind of certain type of machines, so the DS1_v3, and that supports 400 sessions or 100 sessions with transcoding, which is not often used in Teams, but can be used. And then if you need bigger, you can have a DS2 v3 that's 500 sessions and a DS3 v3, which is 600 sessions. So 600 sessions at 100 to 1 is 6,000 people, no, 60,000 people, sorry. So that shows you that if you've got a 600 session SBC, you can support potentially 60,000 end users on that SBC, which is a lot of end users. So you don't need that much capacity to support a large number of people. If we just do a brief comparison with AWS, AWS, we have a slightly different machine type support. So we support, the smallest one we really support is what we call the R4 large, or what Amazon calls the R4 large, and that supports 3,200 sessions. So you can see that's much higher than the Azure ones. As I mentioned earlier on, the Azure ones, we don't have full capacity yet. It's kind of being enhanced as we speak, so it should get much bigger soon. That doesn't actually support transcoding, so if you need transcoding, you need to use the C4.8x large in Amazon. God knows where they get these strange names from, but that one supports 3,200 sessions and 2,500 with transcoding. So quite a lot of transcoding there is possible, and that is G711 to Silk transcoding. If any of you saw the other sessions I did earlier on where we discussed transcoding in much more detail. So you can see there's different machine types with different capacities needed, depending on which cloud you're going into. So we can obviously produce a costing model to let you see how much these cost, but it can be quite complicated to produce these models. There's lots of things we need to factor into it. So we'll look at that in a bit more detail later. What we'll do first of all is just having a look at kind of how we deploy these SBCs in the cloud, where they come from. And the good news is that public cloud tends to have the AudioCodes SBC images available. There are other SBCs available, of course. We have competitors and other companies in this business, but I work for AudioCodes, so I'll talk about them mostly. So yeah, in the Azure and AWS marketplaces, you can just go to the marketplace and type in AudioCodes SBC, and you can find it there basically, and you can deploy it straight away. And it makes for a really quick and easy deployment because we're hooked into the kind of marketplace. We use the kind of init APIs that are available in Amazon, AWS and Azure, which means that we always have the firmware up to date. We deploy the NICs straight away. And also the firewall is set up for suitable values. So AWS and Amazon have their own built-in firewall. And when we install the SBC, we automatically populate the firewall with things like allowing web access into it so that we can manage the SBC, and allowing SIP access in so that we can obviously make phone calls. So the firewalls are sort of set up, and things like DNS are set up already as well. So you don't need to go through it and try and mess around with all these different things and set bits and pieces up. So it's a really quick and easy deployment. Typically takes about 10 to 15 minutes to actually deploy an SBC from the first click to the end of it. So if you need to spin things up really quickly, then it's very easy. And lots of our partners do that. They might, rather than running one big SBC, they'll often run multiple smaller SBCs because it's so easy to turn them on and off when you need them. So you can kind of right size your deployments and bring stuff up and down as you need it. If you want to use redundancy, then when you're having these SBCs, you can use two SBCs, in different availability zones or in different regions. So both Amazon and Azure have the different concepts of kind of dividing up their data centers or their cloud into different zones, so you can get some kind of reliability. Because if you put everything in one availability zone, then typically you've got sort of 2 or 3 nines availability, which isn't necessarily enough for some applications. So sometimes it's best to have things in 2 availability zones, so they're kind of separate parts of a hosted platform. And that at least gives you an extra 9, so you can get sort of 4 nines sometimes availability. But sometimes you need to go even further and run in a different region, so that's a completely different data center. So Azure have got one in London South and one in Ireland and one in UK South and one in UK North, for example. And those are different regions, so they're just not connected at all, basically, with each other. Well, they're connected, but they're not related to each other. So if you run an SBC in one region and then an SBC in another region, you can then sort of get 4 or 5 nines availability because they're in different infrastructure completely. So that kind of redundancy with the SBCs, you can run kind of active-active, as we call it. So you're running 2 SBCs in different availability zones. And if you get a zone of failure or an SBC failure, it means that any calls on that SBC are lost and they have to be redialed, essentially, to bring them back up again. Which for many people is enough. It's not full HA, but it's kind of active DR basically. So you lose the call, spin up another SBC, and people can reconnect quite easily. Or you could just have an SBC provision that's large enough to take the calls. So sometimes that's enough availability to do the availability people need. But sometimes people need more availability, and we can do what we call full call state HA. What that means essentially is that we use an active and a passive SBC pair. So we've got two SBCs, one active and one passive. All the calls are going through the active SBC, but we send the call state information across to the passive partner. And if the active one fails, or the region the active one fails, we normally use a kind of what we call a gratuitous ARP to switch the MAC address and the IP address across to the passive SBC. So that comes up, and then all the calls just flow straight through the passive SBC, and the users don't hear a thing. You might hear a little click sometimes, or you might have like a 1 second delay in voice if you're talking at the time, but you don't need to redial again. You know, we switch the calls across basically from one region to another region, and it all happens automatically. Now, we can't do that in Azure because it takes too long to allocate an IP address on a new instance. It takes about 5 to 10 minutes essentially to get a public IP address running. So we just can't do that in Azure. So if you want a high availability in Azure, we've created a new version of our SBC, which is called the Cloud Edition SBC, essentially. And this is the Cloud Edition SBC. And what it is, we've basically kind of decomposed the SBC. So each of these boxes here is a virtual machine. So that's a virtual machine in Azure. That's another virtual machine. That's another virtual machine, etc. And we divided the functionality of the SBC up. So this box here handles signaling. There's another one handling signaling here. And then we have multiple boxes handling media, and this is kind of horizontally scaled. So if you need more capacity, we just add more and more and more media boxes to give you more processing capacity. So this is why we can grow to 50,000 plus sessions in a public cloud, because we can just keep putting more and more of these virtual machines in as time goes by. So it gives the ability, because we've got separated signaling and media processing, to do this kind of scale out and build out essentially. But we have a single management point, so this still looks like standard SBC. So you can look at it down here, and it looks just like one of our normal SBCs. Just underneath the hood, it's got a kind of complicated infrastructure to give you high availability. But that's the key advantage, really, is the HA functionality that you can get from it. And we have this stack manager that handles the kind of automation, because the other thing this does is allow you to scale in and scale out. So if the traffic starts to fall away, it can automatically sort of turn off some of these media virtual machines, so you stop paying for them basically. So you might only be paying for all of your virtual machines, the media virtual machines, around lunchtime when people are making the most phone calls, but towards the end of the day you can start to turn off virtual machines and start saving money, and it makes a significant difference in the cloud if you start turning off these virtual machines. So this is supported on Azure and AWS. So that's the kind of background to all this, but we've talked a little bit about the costings, so I think it's important to have a look at these now in a bit more detail. So the best thing to do really is try and compare these costs against hardware costs, because of course you could buy a hardware SBC and you could put it into a DC, a data center, and then if you work out how much the hosting space and the power costs, then you can have a quite good comparison of the costs of kind of the OPEX model of Azure versus the CAPEX model of buying an SBC and putting it into a DC. Now the hosting costs do vary quite considerably, but I've got some sample information here that we can use. So if we base this on a 250 session SBC, which is a good size SBC, you can handle lots of users. It could easily handle 2,000, 3,000 users with ease, maybe 10,000 users if you push it, sort of thing. So it's a good capacity SBC. So if you put one of these in Azure, then the virtual machine is going to cost you just £23 a month. So that's not very much money for a high capacity SBC like that. If you do the same kind of SBC in Azure, in AWS, it'll cost you £59 per month, because we use slightly larger SBCs or virtual machines in Azure, so it costs a bit more. If we compare that with the costs of our M800 SBC, this is a hardware SBC that supports 250 sessions. That costs you about 650 quid to buy. That doesn't include the session cost, by the way. I haven't included that price, but I haven't included the session cost in here either. This is just the machine cost. So this £650 here is the cost of buying the SBC, not the cost of buying the sessions, to make it a fair comparison. So 650 quid capex, so that kind of amortizes over 3 years, about £18 a month. People typically write these down over about 3 or 4 years, so that costs you about £18 a month. So that looks quite attractive compared with these kind of costs. But then you have to add the hosting costs in, and it can easily be £40 or £50 a month to host something like an M800 SBC. It's a kind of 1U box. It's not very wide, but it still takes up 1U. So a typical cost could easily be between £30 and £50 a month, say. So it's starting to get quite quite expensive. It's like, you know, 40 to 68 pounds, or 48 to 68 pounds a month, which does look quite expensive compared with the Azure costs. Because obviously if this breaks, you've got to fix it, you know, and if an Azure one breaks, you just spin another one up basically. So there's no real kind of maintenance hardware costs on these. So again, it's much cheaper. But don't forget, there are different ways to think about this, because the AWS machine supports over 2,000 or over 3,000 sessions. So this £59 a month actually gives you a lot of capacity. So buying 3,000 sessions, an SBC, hardware SBC 3,000 sessions would be much more expensive. It would cost you probably £5,000. So it's a lot of money extra. And in Azure, it'd be more expensive as well. So that's not the only cost, of course. The other big cost is bandwidth, which I kind of alluded to before. So public clouds don't usually charge for inbound data. So when you're sending voice traffic in, so people making phone calls in, it doesn't cost anything, but outbound traffic does. So when you're making an outbound phone call, you know, from Teams to a SIP trunk, then that data is going out of Azure into Gamma or into BT or into Vodafone, whoever's your SIP trunk provider. So that's outbound data, and that does start to get quite expensive, because you typically get about 5 gigabits a month free of charge in terms of bandwidth, which isn't very much. If you use more above that, it's usually about 85 pence in Azure, or about just over £1 in AWS per gig per month, that is. So it soon starts to mount up if you've got a lot of traffic going on. And what we found is the bandwidth can easily get more expensive than virtual machine hosting. It can often be 4 to 5 times higher, you know, depending on lots of sort of different reasons. But it can be very expensive. So what's useful sometimes is to consider the impact of using transcoding. You know, if you can send transcoded information down, you can squeeze the voice data into much smaller packets, or much smaller size essentially. So you can typically reduce the bandwidth down to about a quarter of what it normally is. So if you go from G711, you're looking at kind of 80 to 100k, depending on how you measure the bandwidth. If you use Silk, then that may well be down kind of like 12, 15, 20k. So it's significantly less bandwidth than using a G711, but it costs more to run the CPU to do all that transcoding. If you're having G711 in and Silk out, then it'll cost you a lot of money to provide the CPU. So you've got to balance those two things against each other. But just to give you some typical examples, this is quite a big setup. This is 1,500 sessions in use for 10 hours a day. So if you're using G711, that means 19.2 terabytes a month. So it's a huge amount of data is used in voice traffic. If you squeeze that down with Opus, then you get just under 8 terabytes a month. So that's kind of about a third of the capacity. So you can see the cost savings can be quite significant. Yep. So if this in Amazon will cost you $1,800 a month, in AWS it costs you $1,600 a month. If you put the compression on or put the codec on, that comes down to kind of a third of the price essentially, or just over a third of the price there. So significant cost savings by turning on the codec. So it's often worth thinking about. Okay, and also if you use the elasticity I talked about, where we kind of turn on and turn off virtual machines as you're going through the day, you can then take advantage of that and really start to get some more significant cost savings. So you can see the kind of cost savings that we can get. If we've got an elastic SBC here using Opus, then we've got these cost savings kind of out here, which are quite significant. And then you can do different costs models, basically based on different things. But these compare with the monolithic model, where you've got G711, so significant bandwidth costs, but the costs of the infrastructure are smaller. So here you're paying quite a lot for the virtual machines, but you're saving a huge amount of money on the cost of the bandwidth essentially. So there's significant differences in the cost model. So there's lots of kind of different ways of looking at this. And what I actually did for myself is I built my own cost calculator, and it's quite easy to do. What you can do is you can kind of just work out the numbers, and you can do that derived from all the information that I've given you today. And I just basically worked out this thing where I had an Excel spreadsheet where I can put in like the number of users. I could put in whether it's standalone or HA or DR, and then the number of users per channel that I expected. So 50 users per channel, or sorry, 50 users per channel, 100 users per channel, and then it went through a kind of calculation process, and it spits out the kind of virtual machine. So this is in Azure. So for that, I need a DS1 V2, which cost me £23 a month, and then I worked out the bandwidth was £106 a month. So that gave me a total cost of £130 a month. So that's for running that 250 session or 2,500 user setup essentially. If you want to run the same thing in AWS, it's slightly more expensive because AWS for us, and it's not all the same for all vendors, but for small capacities, AWS is usually slightly more expensive for us. As you can see, the virtual machine is a bit more expensive at £59. Bandwidth is roughly the same, but the total cost goes to £190 a month almost. So it's it's about half as much again as the VM costs in Azure. But as I said, that model doesn't always apply. It depends very much on the capacity. If you increase the capacity of the Azure one to about 1,000 sessions, then it would be cheaper to have it in AWS. So you just need to be careful about where you put them. And if you turn on HA and put it through the same model, you can see then you need the different virtual machines that I've written here, because we need these 4 virtual machines to run all the media, and one for the stack manager, and that costs quite a lot of money. It costs £200 almost. And we then need to use the load balancer in Azure as well, which is a service, and so the total cost then gets to £235. So this is a solution for HA in Azure. So that's compared directly with this solution down here, which is not HA, it's just a standalone SBC. So you're paying about an extra £100 a month to get HA in Azure. You're going from that price to that price. So it's not a huge difference, but it is significant, so well worth considering. So these kind of calculators, as I say, can be quite easily written. I would share this one, but it's only half work, so I don't really dare share it out. But if you send me an email, I might be able to share it. Okay, so that's really all I wanted to talk about. It actually went on slightly longer than I thought it, so apologies for that. But just in summary, public cloud is a very popular place to host SBCs. It can be really cost effective. The OpEx model is great because you don't have to worry about stuff breaking down and how power supply goes in the middle of the night. You've got to drive 100 miles to replace it. It's all done for you basically, and so you pay a little extra for it potentially. But in some places you don't. As you've seen, it can be very cost effective way of doing it. HA can be a significant extra cost. You saw then it almost doubled the price, or I think it wasn't. It was about 60–70% more. But HA does cost quite a lot more. And don't forget bandwidth. Bandwidth isn't free, and in fact bandwidth can be, as I said, very expensive. So it can be much more than the cost of the initial virtual machine that you've deployed. But the flexibility in the OpEx model has a really significant advantage in the public cloud. Okay, so that's pretty much all I wanted to talk about. So thank you very much for listening. If you want to get in touch with us, then that's our email address there, uksales@audiocodes.com, or you can find me on LinkedIn, etc. I'm happy to talk to anyone really. Okay, Randy, back to you. Is there any questions in the Q&A?
The only questions we had were actually answers. So when we were wondering whether the session was going live, we had 3 helpful people tell us that we were live. So glad we didn't start swearing about the platform or anything like that. So that's been fantastic.
Yeah, Teams rocks, I believe. Yeah.
Teams definitely rocks. Yeah. Yes. So if you do have any questions, we have a few minutes, or if you'd just like to join John in the breakout session afterwards, I've posted a link in the announcements. Also, don't forget to fill in our survey. Feedback for the presenters is always a great idea.
Brilliant. Thanks, Randy. So I guess we'll hang on here for a minute, shall we, and then just go to the breakout session. And if anyone joins, we'll be there if anyone wants to speak. So if no one's been on a breakout session, then please do join. If you want to ask, you can either turn on your video and have a chat, or just type some messages or speak on audio. It's just a Teams experience, as you'd expect, really. So yeah, I guess we'll go over there in a few seconds. Any other questions popped up?
Yeah, so D asks, great presentation as always. Can you cover session licensing costs, please?
Yeah, I didn't in this instance really, because they were basically the same. So in AudioCodes case, and it may differ with other vendors, if you buy a hardware SBC or a software SBC, we don't charge for software SBCs. Well, generally speaking, there's caveats to that, but generally the session cost is the same. So as an example, if it's and this is just a random example, let's say it's $50 per session. That's the same if it's on a software or a hardware SBC. And then when you buy a hardware SBC, you pay for the hardware, as you saw. So it's $650 to buy a box, or you pay Microsoft to £23 a month to put it in their data center. So the kind of the machine costs are as they are, and the session costs are the same. So think of it as being small scale. It's around $50 per session. As you go up, it drops significantly. So if you buy 250 sessions, it goes down to probably sub $30 a session. If you're buying 10,000 sessions, it's down in the low tens of dollars per session. So there's a real difference in where you go on that scale basically. But you're looking at $50 to say $30 per session is a typical price basically. Okay, hope that answers your question. But if you need more details, just ping one of us, and we can give you a direct quote for how much stuff costs, essentially.
Okay, we got a thumbs up from D, so that's great. Okay. Okay. On that note, if there's no other questions, I will end. And as I said, you got the breakout session there. Okay.
Great stuff. Okay, we'll see you all over there, hopefully. Cheers then. Bye-bye.